Okay. Hello, everyone. Thank you for joining today. We're going to get started. So, thank you, everyone, for joining. Welcome to the AI Machine Learning Workshop. Today's day one introduction to AI and machine learning concepts and real world applications. So, I'm Sacha Balmorgan, founder of Youth Opportunities in Tech Innovation. And I've created this organization to help students with computer science as well as give businesses free websites and applications done for them for free. A little bit about my background. I've been conducting 2 years of AI cancer research, and I've actually went to Tokyo, Japan last week to present my research project in Tokyo University at the International Youth Research Conference. So that's just a little bit of a background about myself. Let's go ahead and get started with what we have planned today. So let's start with introductions for everyone. Since we don't have that much time today, we'll just start with the name, grade, and the state you guys are from. So we can just start with that. Who wants to go first? Or I can just choose someone. That's fine as well.
I can go first.
Okay.
My name is Sajjan Ball Morgan. I'm going to ninth grade and I live in Texas.
My name is Krishan. I'm in ninth grade and I'm in Texas.
My name is going to ninth grade and I'm in Texas.
I'm Hanish Beg.
My name is Sanjana. I'm in ninth grade and I live in Texas.
My name is Avirat Gupta and I'm going to seventh grade and I live in Texas.
My name is Akshit and I'm going to seventh grade and I live in Texas.
My name is Sawil. I'm in ninth grade and I live in Texas.
My name is Hanish Venkaila and I'm going to go to 10th grade and I live in Texas, like all. My name is Harishwar Nagapalli. I'm going to 7th grade and I live in Texas.
My name is
Sushant. In Texas, and I'm going to 11th grade.
Sorry.
My name is Sana. I'm going to 8th grade and I live in Texas.
My name is Yusuf. I'm going to 10th grade and I live in Texas.
My name is Nitin. I'm going to 11th grade and I live in Texas.
My name is Banu.
I'm going to 11th grade and I'm in Texas.
My name is Sam. I'm going to 12th grade and I'm in Texas.
My name is Tarun. I'm in 10th grade. I'm going to Texas.
Okay. Thank you. Is that everyone? Did I miss anyone? Okay. Yeah, perfect. Thank you, everyone, for your introductions. Let's get started. So, just a quick reminder, just ask any questions. This is like an interactive workshop, so you don't have to just listen to me talk all the time. You can ask questions and if you have any inquiries, just feel free to ask them. And if your mic doesn't work or anything, just use the chat, and then I can answer the questions in the chat as well. So let's just dive right into it. So, what is AI? Okay. Can I have a couple of you just like unmute and tell me what do you think AI is? Anyone want to give it a go? Or you can give an example of an AI that we use every day.
GPT.
Yeah, ChatGPT. Okay, that's good. That's an
Claude.
example. What was that?
Claude.
Claude, okay. A lot of LLMs. Okay. What else? What was that?
DeepSeek.
Okay. Good, good. Okay, so those are some examples of AI. Those are really good examples. So most of the AIs that you guys mentioned are LLM models. So they're used for like text processing and chatting. So that's an example. So what we're going to cover today is actually machine learning. So let's dive deep into that. So to understand machine learning, let's take a look at this example here. Okay, we have our input data, we have our model, and in this case, we're going to use the model as our brain. And then we have our prediction. So the first thing we do is when we think of this image, we look at a angry person crossing her arms, staring at us, right? Um, So that's what our brain processes. And we understand this based on previous experiences. We might have seen a lot of our teachers get mad at us or our parents get mad at us and things like this. And since we learn from these experiences, we have this all stored in our database, in our brain. So that way, when we see something familiar, our brain automatically knows, oh, look, your boss is mad at you again. Looks like you didn't submit your work. Okay, so that's an example of what we're going to take a look at here. So that's also how machine learning kind of works, right? We have our input data, and the model learns how to understand the data it's given. It learns from the data, and whenever it's given a different scenario, it can make a prediction. Doesn't mean the prediction's always right, but it does make a prediction. So let's move forward. So we're going to do a quick activity here. We're going to take some time to do that. Let's think of some other examples on how we use prediction. We use prediction every single day. So if you guys want to type in the chat some answers, or if you want to unmute and give some examples, that'd be good.
We can hear you.
Yeah,
There's some.
Okay, perfect. Yeah, from tomorrow onwards, I think we're gonna use a different platform because it doesn't let you to video chat after 25 users. So I think I'm gonna use either Zoom or something else. But I'll put the link in the Discord. So just be looking out for that. That way we can like take a group picture tomorrow. But yeah, okay. Hanish just put kind of predict like in games, like in card games, we predict the opponent's move or play. Yeah, that's a good example. So another good example is like strategies in sports and different things like that. For example, in tennis, when you play tennis, you're not getting the same shot every time, right? Our brain knows and understands from previous experiences how to adapt to changes and different things like that, right? So going back to this example, we get our input data, and that's our muscle memory that we build on through training. And then we have our model, which is our brain, and our brain makes the prediction and does the technique needed based on the scenario, right? So those are some good examples there. Thank you, Hanish, for participating. Yeah, cool. Let's move on. Okay. So machine learning is a type of artificial intelligence that allows computers to learn from data and make decisions or predictions without being explicitly programmed. Okay. So basically, machine learning is kind of how our brain works, right? We're not programmed to do the same thing over and over again. We learn and adapt from different data. So this beautiful diagram here, we have AI, ML, DL, and deep reinforcement learning. So AI encompasses all of these, right? AI is a broad term. There's many things in AI. So breaking it down even further, we have machine learning. So machine learning is a lot of the things like predictions, different things like that. And then if you want to break it down even further, you get into deep learning. And deep learning gets much more complicated because what it uses is it uses neural networks and different types of things like that, where it's harder for us to understand. But deep learning is probably the closest thing to how our own brain works because it uses this type of algorithm that uses neural networks and neurons to understand the data it's given. And it's actually neural networks are really good for tasks like image classification or predictions. In my research case, I was using neural networks for predicting cancer. So deep learning is where you get into much more accurate predictions and different things like that. So you can use deep learning for more complicated tasks. And then there's deep reinforcement learning as well. That basically it's encompassed by deep learning. So we'll get into that later on. But today we're going to focus on one machine learning algorithm. It's going to be linear regression. So I'm sure you guys heard of linear regression before in your math classes. So we'll get deeper into that today. Okay, so machine learning here. And the difference between regular code and machine learning code is instead of spending hours of code, coming up with the same exact test scenario, there's like thousands, millions, and like almost infinite amount of possible situations you can use for a given scenario. For example, like going back to the boss thing, there's a bunch of different ways your boss can like show that she's angry. And we don't have the time to code if my boss smiles a certain way, she's mad at me. If my boss, you can't just write a bunch of if statements because that would just you'll keep writing forever. So instead of hours of that code, machine learning learns and adapts from data. It makes a prediction. And like I said before, the prediction is it's not always correct, but it's there. It makes our lives much easier. So it works just like a person. It learns along the way, and the more data you give it, it's gonna learn much more. So that's how it works. Let's see. Since Okay, Loki, we just started like 10 minutes ago, so you didn't miss much. I just saw your message right now. Um, yeah, it starts at 5 p.m. CST, but thank you for joining. Why don't you just quickly introduce yourself so everyone just knows? So just say your name, your state, and your grade. Okay, that's fine. We can just introduce you next time. That's fine. Okay. Okay, let's just continue on. So, to understand machine learning, there's two categories. There's supervised learning and unsupervised learning. By show of hands, I think you guys can raise hands. If not, just like put in the chat if you guys know what supervised versus unsupervised learning is, or if you can make a guess on what it means based on just looking at this image. And I'll show you the image of unsupervised as well. So, supervised, unsupervised. What do you think that means?
Watching people learn.
What was that? Watching people learn. Mm-hmm. Looks.
That's what he said, I'm pretty sure.
Okay. Watching people learn. Interesting. Okay, we'll just put that out there for now. I'm just reading what Hanish is saying right now. Supervised probably means that it knows what it's looking at, like supervising. Okay, Hanish, that's a pretty close definition, so that's good. I'm just waiting for a couple more people to just. Training the animal. That's also a good response, Nate. Okay, supervise this. Okay. Okay, yeah, Dia, you're going in the right direction. Okay. Label. Okay, Ritvik. Okay, you're getting closer. That's good. Okay, so supervised learning is where the model is learning from input data. So let's take in the example of the cat and dog, right? We're telling the model, okay, hey, this is a cat, and here are a bunch of images of cats, and this is how a cat looks like. And I'm telling you, this data set is just for cats. And here is how a dog looks like, and here's a bunch of images of different types of dogs, and this is a data set of just dogs, right? We're telling the model what the difference, well, not really the difference. We're just telling it, okay, here's a cat, here's a dog. Now figure it out and figure out how to learn something, right? So let's take an example of school. Let's say supervised learning is your teacher telling you you're learning AP statistics and you're another teacher telling you you're learning AP biology. Now you have the data set for AP statistics and AP biology. And if you're ever in a test, you know where to use your knowledge in. You know, hey, I'm answering questions on AP statistics right now, not AP biology. You know how to differentiate between the two data. So that's kind of how that works. So that's supervised learning. So based on what I said, unsupervised learning is pretty much the opposite of that. This time, unsupervised learning is, if you notice, we're not giving any labels. We're not saying this is a cat or this is a dog. We're just saying, hey, here's a bunch of pictures of animals, and what you're going to do now is figure it out. Tell me what you think it is. Just differentiate it. It's not going to know it's a cat or a dog. The name is not what it's trying to figure out. It's just trying to sort it out and figure if it's a cat or a dog. So the model has to learn some more. It has to figure out how I can differentiate it. What am I looking at? Am I looking at color? Am I looking at texture? Am I looking at size? Am I looking at different things like this? The model has to figure that out. So that is how that works. Okay. Any questions so far? I'll just pause here for a little bit. Anyone have any questions?
So just making sure, so like supervised learning is like you gave it labels and then it's just organizing it from those labels.
Mm-hmm.
Then unsupervised is just the opposite, like it's just looking to attributes.
Yeah, you have a very good understanding of it. It's basically supervised is, let's take in a model that's trying to predict if you give it an image of a dog or not, right? It's trying to say, we're given, when we train the model, we're given like cat images to it, and we label it as cat images. We say, hey, this is cat images, understand this data. Here's dog images, understand this data. Okay, then the model trains on its own, and when you give it a cat image, it'll tell you, oh, it's a cat. I know this because the cat images you gave me looks right. It understands, okay, since you gave me the labeled input, I know what a cat looks like, so I can tell you this is a cat right away. But when it's unsupervised, you're just feeding in a bunch of animals, and the model, it separates them. So when you send in an image of a similar animal, it won't tell you it's a cat or not. It's just going to tell you, hey, it's animal one. And I know this because of these features, right? It's going to separate it on its own. It's going to create its own data set where it tries to understand what the data is. So it makes its own cat and dog data set, basically, instead of it being like given that way, like separated that way. Does that make sense?
Yeah, I can understand now.
Okay, perfect. Anyone else have any questions? Yes.
Is there an option to choose between supervised learning and unsupervised learning?
Yeah. That's how you would program it when you get into the programming stage. It depends on the model you want to do. Most of the time, we're going to be working with supervised because that's the most common. So, some examples of supervised models is like linear regression, logistical regression. So, these are just examples of models you can use. And then there's also models that you can use for unsupervised. So, I think I have a slide explaining it even further. Yeah. So a K-means is a type of model that's unsupervised. So let me try to explain unsupervised learning a little bit further, just for understanding. But thank you for your question, Monvik. So basically, before K-means, so this is we're just feeding in a bunch of data, and if you notice, all the data looks the same to the model, right? And after we perform the k-mean, so after we do our model, we run the model on it, it's separates it into three groups. And you notice orange, green, and red. And let's just say this example here is a bunch of emails thrown at the model, okay? And the model has to now separate the emails based on some criteria. And the model, after separation, comes up with three criteria: school, family, and spam. So that's how you would use unsupervised learning when you don't know what you really want to separate and you just want the model to kind of figure it out and separate it for you. And then you later examine the separations and give it a label. So it would be initially just plain, but afterwards you're done running the model, it would you can go in and be like, okay, hey, these look all school related, I'm gonna label this group as school. So you're doing the labeling after the model runs, but the model already separated the groups for you. But in supervised, you're doing the labeling before it runs and separating it, and the model would just predict it. Does that make sense? Okay. If everyone is good to move on, can I just get like a thumbs up on the chat?
Can you explain that again? I couldn't catch that.
Which part specifically?
Like, can you just like redo that slide?
Yeah, sure. So basically, how it works is you have the before k-means. So k-means is the model you're running for unsupervised learning. And let's just say in this example, you're just feeding the model a bunch of emails. It doesn't know what the groups you're splitting it into. So right now, this is how it looks. So after it performs that k-means, it's split into these three groups that it came up on its own. So the model is like, okay, hey, these look similar in email, so I'm just going to create a category. And it creates three categories: category 1, 2, and 3. So right now we have three groups of no labeled data, but you can go in afterwards and label it. So let's just say the first group, the green group, is school, orange group is spam, and red group is family. But the difference between unsupervised and supervised here is that supervised is already getting that data split in the beginning with the labels. So it knows what cat and dog is. It doesn't need to go figure it out. It doesn't need to go separate it on its own like this, unsupervised. Does that answer your question, Sudden?
Yeah.
Perfect.
Is machine learning more similar to supervised learning or unsupervised learning?
So machine learning encompasses both. but you'll see supervised much more than unsupervised. Like I was telling you, machine learning has a lot of different algorithms you can use. Some of the most common supervised learning models I was mentioning before were like linear regression, logistical regression, and then unsupervised would be k-means, like my example here. So depends on what you want to use really. So if you want to do like a prediction type model and you already want to feed in the data, you can use supervised. But if you want to discover something new or try to make the model like figure things out, you would use unsupervised. Does that make sense? Perfect. Okay. Um let's see how I can do this. Okay. So let me explain it a different way. Okay. So let's not get too confused here. So supervised learning, to make it really, really simple, is we're given in this example, we're giving two data sets and we're saying these data sets are called cat and dog. So the model now knows that we have a data set of cat and dog, and then it can make a prediction based on that. So if it sees a cat image, it'll know right away it's a cat. It doesn't need to separate all the images and understand what the difference is between the animals. It can easily figure out the difference with the data given there. Then unsupervised learning right over here, you're not telling it it's a cat or dog. You're just giving a bunch of cats and dogs images, and you're just saying, hey, learn what this is, what's the difference, and create me two groups. Then it learns and then it creates two groups of animal one and animal two because it doesn't know what a cat and dog is. It just knows to separate them, and it's separating them based on some characteristics. This cat has whiskers, so if an animal has whiskers, it goes in group one. If an animal doesn't have whiskers, it goes in group two. Does that make sense? Perfect. Okay. So are we all good to move on?
Yes.
Perfect. Cool. Let's go to the next slide. Okay. Whew. Now time to get into machine learning and how the algorithms goes. So this next part of this course is gonna go heavy on the logic and equation side. So don't get too caught up on the equations because, to be honest, you're not gonna really need it because the code itself will do all the complicated math stuff. It's just to help your understanding on how this works. Okay. Let's start with the training stage. So training is stage one. So we feed in the input data, and then we create our learning algorithm, and bam, we have our machine learning model. It's pretty simple. And then our inference stage two, we're given new data, so data that's never been seen before. We have our machine learning model that we just trained, and the model makes the prediction. So that's kind of how it works, right? To put in a very, very high scope. Um, yeah, that's how it would work. Let me just break it down even further. So I'll start with the stage two because it's easier math wise to understand conceptually. So let's first talk about the model I'm going to be explaining today. Today, I'm going to be using a supervised learning model called linear regression. Okay, yeah, and we're back. Okay, like I was saying, it's basically if you guys took in statistics or if you were in AP statistics, I'm sure you guys seen this equation before. Y hat equals WX plus B. It's a very simple formula. It's just a slope formula, right? It's the same thing as y equals mx plus b. And all it does is it creates the best fit line here. And it's making inferences based on data. So we're given it the data, and then it takes all these data points and makes a best fitting line. And then if you want to make a prediction, for example, let's take an example of, let's see, let's do study hours and scores. Okay, let's just say this is a positive sloping line here. And the more hours you study, the more good grades you get. So let's just say the line predicts, if you study 4 hours, you get that's 90% on your next exam, right? But let's say there was already data there for 4 hours, and let's say it was 88%, right? It's just all this is doing, this linear regression, is making a line of best fit and making a prediction based on that. Let me just go um, deeper into this. So we have our input value, which is x. So this is the input we're going to give it. So a bunch of the data, we're just going to give it here. And then y hat is our prediction. So that's this line here. That's going to be our prediction, right? We give it the input and it makes a prediction. So what is w and b? Well, w and b is our parameters. And how we adjust these parameters like make a result for the prediction. So if we adjust it in a bad way, it's going to make our line look weird and totally wrong and not correct at all, right? So how do we get these parameters and how can we adjust them and find them for our equation, right? So that's what we're going to learn how to do in the next stage, stage 1, training. So in training stage, it fits the model's prediction to the true value. Okay. So to do this, we have this thing called the loss function. And the goal of the loss function is to get the smallest loss possible. And for a linear regression model, you use this thing called mean square error. And that's your loss function. So this is the equation for that. And if you notice, what is this? Y hat. And what is y hat? This equation right over here, right? So what it does is we can now plug in that equation that we got from our previous stage, or I guess our next stage, stage 2, and plug it in right over here. And now we have our parameters. And we adjust these parameters to minimize the loss and get close to the true value. So the more we adjust them, and the goal is ultimately to get the lowest possible loss, and that means that it's going to be more accurate. So I'm just going to pause here just so because I said a bunch of information and I want to make sure everyone's understanding it because this is a little bit important. So if you guys have any questions, please ask them now.
So like you're using this loss function to like kind of like narrow it down, like deducting all the options to a closer result.
Yes. So the lower the loss function gets, like the result of that, the closer and closer it is to the actual like results, the true value, I guess, you would get. Does that make sense?
Yeah.
Okay. And yi, yeah, go ahead.
Yeah, I'm kind of confused about this part.
Mm-hmm.
So, like, can you like break it down a bit?
Yeah, sure.
Please?
Do you want me to go to the stage 2 or just stage 1?
Stage 1.
Okay. So, all right. Let's break it down even further. Let's go back to this equation. It looks less scary. This left part you don't really need to worry about too much. It's just a summation, so it's just adding up all the outcomes for like all your input values. So let's just say you input in 10 data points, you're just doing this 10 times. You're just adding it. So you do whatever value y your input value. So y is your input value. So that's the same thing as your x here. That would just be your input value, and that's your function from before, this function here, wx plus b. And right over here, we're trying to adjust these parameters to get the smallest loss. So that loss, this mean square error, the lower this is, that means our model is more accurate, right? So let me just go on to the next slide so you'll like understand it a little bit more. Because right now, you guys are probably thinking, how can we possibly know what W and B is, right? Well, we can always just randomly guess, but obviously that's going to take forever, and it's not like the best way to do it because you're never going to get the right answer. So there's actually something you can do. So how do we know what our parameters are, right? We can use this optimization algorithm called gradient descent to adjust W and B. So using this algorithm here, you're able to figure out what values to do for W and B, and the computer will do it all of this for you. This is just to understand how it works. How it works. So it would give you an output, and the more you train the model, the more it'll adjust and do this gradient. It'll keep running this gradient until it either times out or it's found the most optimum strategy for you. So it's going to keep, basically what it does is it goes through different types of combinations of W and B and uses the same function from before, like our MSC, and it's trying to find the perfect W and B to use to minimize the minimize.
Yes, I can hear you. Yeah.
Yeah, it is.
Okay, I thought my screen just froze for a second. Can you see the screen?
Yeah, yeah.
Yeah.
Okay, so you heard like everything I was talking about, right?
Yeah.
Perfect. Okay. Where was I? Parameters. Okay. Yeah. So we're basically the gradient function. What it does, it'll find you your parameters using that equation, and it's gonna keep trying different parameters through that equation until it gets like the most minimum loss function. But another key thing that plays a big part in this is the amount of data you have. So the more data you have, the closer and closer you will be to like the true value. So I'm sure you heard of this in like if you took AP statistics, I'm sure you heard of like the mean value theorem or something like that. The more data you have, the more and more closer you get to the like the true prediction. So same thing when we flip a coin, right? We keep flipping a coin, and of course, like when we record like 10 data, it's not going to be exactly 50%, 50 for 50 like percent chance. But the more we flip it, let's say we flip it 100 times, you get closer and closer to 50%. So same thing with the loss function. The more data you have, the more values you give for the summation equation here, the more accurate it would be, and the lower you can make your mean square error. And the lower that mean square error is, you'll have a better fitting line here. So that's all it does. So that's your training stage. And then it uses those parameters that you got from your training stage and uses it for W and B here, and it feeds in your input data and it creates a prediction. That's it. Does that make sense?
I can't see the stream.
You can't see the stream? Is it frozen?
Wait, it's just frozen. I think it's not moving.
Okay. Let me just reload the screen. I might disconnect for a second. Give me 1 second, guys.
What's the correlation between these mathematical theorems and AI?
Give me 1 second, real quick. Can you guys hear me?
Yeah, I can hear you.
Perfect. Okay, can you see the screen now?
This is so much.
Okay,
So
can you
like
guys...
on the slide where it was the y is equal to mx plus b.
Yeah, I see it.
Okay, perfect. Okay, so Ritvik, to answer your question, all of this that I'm explaining is actually part of machine learning and AI. So this is a type of AI model. It's called linear regression, and that is basically what I've described. And I just told you how it works, like the math behind it. That way, you'll know what to do when you actually like program the AI. So this is the theory behind how it works. Does that make sense? Okay. Do you guys have any questions about this? Do you want me to explain that last bit again, since I can see the screen?
Yeah.
All right. Perfect. I'll do that. Okay. Let's see. Okay. So, what was I saying? Let me talk about why it's important to have a lot of data. Like I was saying with the coin flip example, the more data you have, the closer you get to the true value. And so that way, the more data you have over here, this this function here will do more combinations of data. So whenever you like write your script, you'll tell your model how many times you want to run it, right? That would get more into deep learning stuff, but you can tell your model how many epochs you want and different things like that, and it'll just run it multiple times. So how many times your model runs, it'll do different combinations until it finds the most optimum combination to get the lowest amount of loss here. So whenever this loss is like very low, you'll get a very accurate line of prediction here. And whenever you get a very accurate line of prediction, you can now make an more accurate AI, and your AI can now predict more accurately, right? So let's see. Yeah, okay. So like I was saying with my study example, the more you study, the better grades you get. Let's just say this was positive sloping. Um, so then you'll have a more accurate line that will tell you the most accurate prediction for your class. Does that make sense, to put simply?
Yeah.
Okay. Do you guys have any
Yeah.
questions?
Any questions?
So like this linear formula here is just like to create like the prediction over here, and
Yeah.
then like we use the other formulas like to narrow our like results.
Mm-hmm. Yeah, you got it almost perfectly. So inference stage 2 is basically where we actually create the model to make the prediction, and then training stage is where the model fits to the true value. So the model is trying to find the right parameters to use and minimize this loss function to get close to the true value, so it can make an accurate prediction in this stage.
So like the first formulas are like just to create values near to each other, and then this one is like finding a point that's like close to each point.
Can you repeat that again?
So like the before formulas, right? So those are there to like create the values that are going to be near to each other, and then like this linear formula is just there to like make everything like near the outcome.
Yeah, perfect. Yeah, so this linear formula in stage 2 is your actual formula that you will use for the prediction. So the W and B parameters, how we get those is through this stage here, the training stage here, right?
Oh, okay.
Does that make sense?
Yeah.
Okay. And the goal of those two values is to make this as low as possible, and that's how it runs through these two equations here to get the most optimum number. Like, let's just say this is 3 and 2, and then you plug in 3 and 2 here, and then you get your input value and you get your prediction. Yeah, that's basically it. Okay, we have like 10 minutes, but I'm sure that we can run through at least one activity. So, did you guys see my message on setting up Jupyter Lab, like the Anaconda thing? If not, we can just run through it real quick on this call.
Because I don't get it.
It's on the workshop channel.
Settings.
If you guys go down to like the mentoring tab, there should be like a workshop channel. Can you guys click on that? Do you guys see it?
Yeah.
Yes.
Do we download the distribution or the mini conda?
Let me see. Hold on.
This is download Anaconda distribution.
Yeah, the distribution, and then you just put in your email address and then click submit. Or I think you can skip registration. There should be a button.
Wait.
Yeah.
But it says I have to leave Discord for that.
Yeah, you do. Here, how about I do this? I'll stop streaming.
Wait, so are we supposed to download both?
Here, I'll just walk you through it. Hold on.
Should I put my mom's or should I put mine?
You don't need to put your email. You can skip that part, actually. So if you guys go Can you guys see the whatever I'm saying right now? Can you guys see this?
Yeah.
Okay, yeah. You click on that link I sent. Click skip registration, and then you can just download it. You choose the distribution installers, and then click on whatever. So I'm using Windows. I'll just do it with you, and it'll download Python with it. You can just click on that, and it's gonna download. Once it downloads, since I already have it installed, could someone else stream so I can just see what and show you guys the next steps?